Today, um, we will be talking on the lens aspects and other topics. Yesterday, we talked about the camera components. What makes a camera? There are many components that make a camera. Some of the key components that is relevant to us as engineers of project design, project implementation are what are the types of cameras, metal, plastic. We talked about the vandal resistant for the camera. We talked about the different type of lenses for the camera. Then the CPU or the SoC, system on chip. It's not just CPU with other components that makes the system on chip. System on chip is responsible for three major uh, expectations from the camera. One of them is image processing. You may recollect that we saw WDR yesterday, we saw IR, low light, thermal camera, PIRIS, DCIRIS. We saw all of these image related techniques yesterday. Who's doing that? The chipset is actually processing all this information. If there is too much sunlight, the WDR has to kick in. If there is very little light, low light features have to kick in. Similarly, PIRIS and other image aspects or image settings will kick in real time to make sure usable image is produced, right? As soon as the camera is looking at a specific area, uh, maybe dark, maybe bright, it has to produce useful image, something that you can make sense of in real time. So that is the job of the camera and the chipset. Next is how good it can compress the image. We will see all of this in the coming days and slides. Then analytics, we will also be looking at it. Okay. Now in the camera, we talked about IK10 rating. What is IK10? Vandal resistance or impact resistant. Someone trying to damage the camera with a physical force, physical impact, and the camera can withstand it. That is called vandal resistant. There is also environmental protection of a camera. We, most of you already know this part. IP66 rating, IP67 rating, IP65 rating. You might have come across this. Um, Ingress protection, IP rating. Let's just open a small reference and we'll just quickly go through it so we don't miss this point. Go. Just IP rating. Any camera which you use outdoor should be protected against dust, dust tight. IP66. Okay, so this is how it is written. IP66 or IP65. The first digit represents solid protection, which is the dust related. Second digit is for water. Nowadays, also your mobile phones are waterproof because they have this extra rubber seal which protect water from getting inside, right? So this is water protection. You can have IP60, 6 and 0, which means it is fully protected against dust but not against water. That can also be a case. So do not look for just one number, make sure both the numbers are there. The safest number for outdoor is IP66 in the Middle East because you also have rain, you also have fine dust from the sand, so you need both. And the best for outdoor rating is IP66. What about indoor? Not required because you have TV at home, you have everything at home. You don't put waterproof protection or anything, right? So you don't really need unless it is in the kitchen, unless it is in area where there is water. There is a chance for water leak and all that. Maybe in a mechanical rooms and certain utility rooms, you can have some IP rating for water. But otherwise, for indoor applications, you don't really require any IP rating. Okay, and let's go forward. We talked about WDR. highlight compensation. We talked about low light. We talked about again illumination. Zoom IR. This is the concept where the IR beam zooms in with respect to the zoom of the camera, especially for PTZ. There is a lens and there is a IR LED. Okay, then IR corrected lens. This is not very critical for today's course, but for your information, there are two types of light important in CCTV. One is the visible light and then the IR light. If you're into perimeter monitoring, if you're into outdoor monitoring in your projects, you have to know that visible light has a specific focal length. I mean, it focuses at a specific point. IR beam, this red light on the top, IR beam will have a different focal point. All right, so that means you have to refocus the camera. Oops, sorry, visible and IR. Okay. Now the same camera at night time, it's blurred out because the focus of IR beam is on a different point. So it has to be readjusted. However, if you use IR corrected lenses, even in night time, it makes sure that IR beam is also focused at the same point. Okay. Very few cameras or series vendors will have these small things implemented into their lenses, especially for critical cameras, PTZ cameras, and other outdoor cameras. So just make sure if you have a requirement where nighttime monitoring is critical. Okay, again, I emphasize this because whenever you do test or a user acceptance test or a proof of concept, or when someone comes and displays their product in your showroom, in your office, in your property, you verify it in the morning time. Morning time, everything can look beautiful. And by evening time, we all go home. But if evening time monitoring is also critical, you should do a POC even at the night time and make sure you're getting crisp images even at night time. Okay, and that's something you can keep note of. All right. Every camera, there is a focal length. We talked about it yesterday. Uh, Lens ranging from 2.8 to 12. This is the most common lens, 2.8 to 12. Why is it most common? If I go ahead and take one camera, okay. So let's say this camera has got around up to 10 mm. If I uh, want to zoom in, it's looking at the door, right? So let's say I'm going to zoom in. First zoom out, make sure I'm all the way at the back. Okay, so the camera can see almost the entire room. If I zoom in, okay, Now this is the maximum. This is your typical common lens, 3 to 10, 2.8 to 12. This is the typical range of how much it can zoom in and zoom out. Okay, I'm zooming all the way back. All right. Now what does this tell you? If you zoom in, this camera cannot cover who's sitting at the meeting table. It cannot cover the meeting room. It can only look at the door if I zoom in, right? So right now, let's say I'm at 10 mm, 2.8 to 12 or 2.8 to 10. Right now I'm at 10 mm. So whenever a camera is installed in a property, uh, the idea is to keep the cost in mind, right? So you will use the camera to cover as much area as possible. You will not start after the meeting room, right? Let's say you're monitoring corridor. You will not start after 10 meters. So this is like 10-meter distance. So you will try to cover as wide as possible. Whatever the camera can see, because you're already investing in the camera, you will try to monitor as wide as possible, as much area as possible. All right. So very few locations you will be asked to focus in. Maybe due to privacy here, you don't want to monitor who's sitting and discussing, or maybe you are only interested in the door. Then you will zoom in. Otherwise, most of your projects you will keep it zoomed out. So right now, zoom in. Previously, I was zoomed out. Okay. Now, when I said privacy, door, all this is not a day-to-day requirement. I mean, in your public property, of course, you want to monitor all the areas, right? Waiting area, lift, lobby, storerooms, and everything. Only certain locations, entrances, you are interested in the door because you want to know who's coming in through the door with the full detail, like a clear, more resolution you require for this area. Only for those locations you will actually zoom in. Otherwise, you will keep it as wide as possible. All right. So this is varifocal lens, standard varifocal lens. Why it is usually 2.8 to 10 or 3 to 10 or 2.8 to 12? This is the reason because not uh, you can take a thumb rule. Every is like 1 meter blind spot. So if you start at 10 you are losing 10-meter coverage. No one will buy a camera and put in the corridor and start after 10 meters because that's waste of money. All right, so most, I would say 95% of your typical project locations, you will keep the camera at a wide angle at 2.8 or 3. You will leave it at that location itself. All right, okay. Of course, you need projects where you need longer lens. Maybe the distance from the camera to the door is very far. Maybe the hotel, the nearest place to mount a camera is like 20 meters. The ceiling height is very high. You cannot put the camera. In that case, you will, uh, okay, let me explain this point. Okay, if you put the camera exactly on the top, let's say in your project you have a ceiling height of 7 meters or 10 meters. If you put your camera on the top, you will only see the head of the person. You cannot get the face detail clearly. That's why we try to keep the camera as uh, as low as possible to get the face details clearly. So if I am walking through the door, you can see my face clearly. If I keep it on the top, you will only see my head. Okay, then and yeah, all right. Focal length. So what is the takeaway? The more you zoom in, the more the coverage becomes narrow. So if my camera is here and if I zoom out, I'm looking at a wide angle. But if I zoom in, my drawing is poor. Okay, if I zoom in, the angle is narrow. Here, let me open the PowerPoint. camera. As I zoom in, as the focal length increases, the angle of coverage becomes narrower. Okay. Okay. Now, if your angle is very narrow, that means you need a lot of camera to cover a wide area. You can only see maybe 1 meter. If your room is 10 meters, you need 10 cameras if you use a very narrow angle. So, however, if you use a wide angle, you need only one camera. Okay. Now, there is some conditions which we will see, like identification, detection, and so on, and that will determine what lens is required for a project. Okay. Now, PTZ cameras. PTZ cameras are using zoom lens and they have very large focal lengths, 4.75 to 261, 6 to 222. Yesterday we saw, right, a PTZ camera zooming in all the way to the end of the highway near the port. So I zoomed in and I showed you the PTZ camera. How does it work? Um, why is it called 55x zoom? Okay. So if a PTZ camera is called a 55x zoom. That means from 4.75 from this focal length, you can go 55 times. So 4.75 into 55 times is 261. 261. So this is why it's called 55x, right? So 55 times it can zoom. It's optical zoom. It's not digital, it's optical zoom because the lens is zooming in. Okay. Okay. All right. So I have a question. This camera, he asked me, why can't we put this camera above the ceiling near the door to focus at the door? Yeah, that is possible. No issue. This is my training room. I have put it intentionally to demonstrate a few things. So that's why there are cameras here as well to look at the. You can keep the camera because the ceiling height is not very high, so you can keep the camera even at the ceiling here and look at the person. All right, can be done, no issue. However, there are locations where the ceiling height is if it is very high, then you, let's say 6 meters, 10-meter ceiling, double ceiling, triple ceiling height, especially at hotel main entrance lobbies. Let's say you go to Atlantis, you go to Jewel of the Creek. Certain projects, when you enter, there is no ceiling. You have to walk at least 10 meters, 20 meters to go to the reception desk, and then you will have just poles around, column poles. So you will see cameras mounted there and with a very big lens zoomed in to the door. Okay, so the purpose is to get the face details clearly. All right, now back to, okay, okay. Can I explain 50x one more time? Okay, focal length is smaller focal length means wide angle, large focal length means narrow angle. You can zoom further. How do you get the optical ratio? 30x. How do you get the optical ratio? You divide 261 maximum focal length divided by the minimum focal length. Oops, yeah, 261 divided by 4.75 will give me 54.94. So it is rounded up and it is mentioned here as 55x zoom. What about 222 divided by 6? 37x zoom. Okay. Now, even for standard cameras, it can be mentioned, for example, 4.3x. It's not a PTZ camera. It just means 12 divided by 2.8 is 4.28, 4.3 times zoom, motorized varifocal. Okay. Now, for a PTZ camera, this one, pan tilt zoom camera, it can rotate left, it can go up and down, and it can zoom, pan tilt zoom. Uh, Higher the focal length, very good, as well as lower the focal length, very good. If you have uh, 10 mm, let's say the camera starts at 10 mm, that means you have a very narrow angle. Starting angle itself is very narrow. So your PTZ will not be able to monitor a very large area. So you want your camera to monitor as large, as wide area as possible, as well as narrow as possible. Okay. If your objective is only narrow, then it's okay. But if you want to do general monitoring, what's happening in the entire street, for example, let me pull out that camera once again. So if my PTZ camera had a very narrow angle, I will not be able to get this wide view. Probably it will start, like, let's say it will have a little bit narrower. If it is, it might have a narrow view like this. So you cannot get a very big angle. So you should have both for a PTZ camera. Next is, what is a digital zoom? After you zoom in all the way, then you can do digital zoom. Just like you take a photo in your mobile phone and then you explode the image, that is called digital zoom. So it's called blowing up your image. So just a second. So let's say I have taken, this is, right now I'm looking at a person. Now if I zoom in, this is called digital zoom. I'm blowing up the image and the image gets, you can say, slightly pixelated. So this is digital zoom. Optical zoom, the image quality does not reduce because it is optically zooming and you're still getting the full resolution at that entire scene. So even after I zoom in, for example, even after I have zoomed in, I'm still getting 2 megapixel video from this scene. All right. So this is called optical zoom. Okay. All right. If you have any further questions, you can post it on the chat window. Now, another point, a camera, you can look at that entire scene, right? My camera can look at the entire port. My camera can look at even the sun. If I try to look at the sun, I can look at the sun. If I try to look at in the nighttime at the moon, I can look at the moon. But does it mean I can see millions of kilometers? Probably, yeah, it can see that, but you cannot make any difference. The moon looks the same. There are so many things happening in the sun and the moon, but you will not be able to notice, you will not be able to detect any change. So there is a criteria in CCTV. It's something that we take it as minimum in our region. It's called detection criteria. what is the minimum amount of resolution quality required to achieve or to make sorry, to achieve detection, basically to detect any change in the scene. If there is someone moving in the scene, if there is a car in the scene, if there is some activity in the scene, in order to detect with your human eye, you need to have a certain level of pixels available in the scene. So that is called detection. If your camera cannot do detection, then there is no point in camera. It's just a decorative piece, right? Because for security, it is not achieving any function. You cannot do any detection. You're just monitoring, just like you're watching YouTube. It's gonna just show you everything. All right. So, however, um, it does not stop at detection. You also have other parameters: recognition, identification. Detection does not tell you who the person is. It only tells you there is some level of activity, there is some car moving, there is a person there. That's it. All right. But there is two more levels which is important for any CCTV camera is recognition and identification. Now, this, let's say, how do you explain this? Is a simple way. Just let me pull out the, just a second. Okay. This is a close-up photo and you have identified me, right? This is how I look. Now, if you see me somewhere in a lobby, somewhere in the hotel, or somewhere in your place, let's say we catch up in some supermarket somewhere, you will recognize me. You will recognize me because you have looked at this photo, you know this is Samuel. You have already registered this, identified that if someone who looks like this, wearing a glass and a hair and all that, this physique, this particular person is Samuel. So you have already identified him with a very closer photo with the facial feature. And if you look at him somewhere else, maybe walking around some 20-30 meters somewhere distance from you, you will still recognize and say, hey, I know this guy, this is Samuel. It's like just like you recognize a friend, although he's walking at a very far distance, right? So you recognize him. You're able to recognize because you have already identified him. You know how he looks, all right? So that is the meaning of identification and recognition. So in order to do recognition, you have to first identify. In order to do recognition, you have to first identify. Then only you can recognize who it is. Identify means Samuel. This is Muhammad. This is Ahmed. This is Kumar. This is whoever. So once you know this person has a name, then whenever you find a photo, whenever you find this guy walking in that CCTV scene, you know this is the same guy. This is called recognition. All right. Then strong identification we will see later on. Uh, so not every area requires identification, not every area require recognition, but everything requires at least detection. Okay, so all this comes from a specific standard, EN standard, not something best practice. It's a standard by default, how many pixels are required to make sure you get enough details from the scene. Okay, now, okay, pixel per meter, ppm. How do you make sure your camera has achieved a detection? Your camera should get at least 20 pixels per meter. How do you make sure the camera has reached recognition? 125 pixel. Similarly, identification is 250. Now, this is a reference from a third-party website to explain. If you take a picture at 500 pixels, the face of the person is very clear. the number plate details are very clear. If you take the same image, 400 pixels, again, the face is clear enough, details are clear enough. 300, still you can identify and say, all right, this is person so and so, and number plate is clear enough. As you go down to 100 pixels, you start to see the details deteriorate. He might have a brother who looks the same, or there can be some of his same relatives who might look the same. So this is not a sure shot picture. You cannot say for sure this is person A. It is not possible with this image quality. All right, unless and until you have a reference. Right now, you are sure this is the same guy because you have a reference here, and then you try to compare it with this picture. So this is called recognition. Again, recognition. Detection. Do you see detection 50 pixels? You know there is a person, you know there is a car, but you cannot really, when you digitally zoom, you can't really get the details. Okay, okay. Now let's see. Okay, okay. Now, you can, okay, now there is a common mistake amongst uh, typically, maybe consultants or even integrators, designers. There is a common mistake is, all right, so why don't I just to specify 300 pixels for my entire project? If you do that, then you will end up giving at least 20 cameras for covering the entire parking lot. Okay, 10 to 20 cameras you will need to cover the entire parking lot because your expectation is 300 pixel per meter. So you cannot say I need identification in my entire project. So that's why you have to have a good balance. Where you need detection, which area you can use identification and recognition has been, it should be clear. Okay, very simple thumb rule. Whenever you're going to look at a person for the first time in your property, you need identification. What is this first time? Reception, main entrances, parking entrances. This is where you look at a person for the first time, right? Then, of course, those locations, make sure you get identification. What about recognition? Everything else. Simple, right? Main entrance, all identification, everything else, recognition. However, exception to recognition is very large areas, large gardens, large parking areas, uh, public surveillance. Those kind of locations you need to let go of recognition a bit. You can use Ptz camera to do general detection. If something happens, you can zoom in and find out what's going on. Okay, so this is what you can look at as a detection parameter. Okay, now there are tools available. Uh, every vendor has their own tool. Then there are also online free tools available to do this calculation. So I will explain. First, I will explain the free tool. You can use jvsg.com. So on this website, there is a free version called Lens Calculator. You can take this. Okay. Now, if you're doing a design, you don't have to choose any manufacturer. However, if you are very specifically working on one vendor, you can choose a particular brand. you can choose a particular model. Otherwise, go with 1 by 3 inch or 1 by 2.8. These are common lenses and a standard, sensors. And the standard lens is 3 mm to 10 mm, 2.8 to 12 mm. So we can start with 3 mm and leave it at 2 megapixel. Let's say the person is standing at 15 meters. Right now he's standing at 15 meters from the camera. The view on the right side, 74 pixel. It is lower than recognition, right? What do you require for recognition? 125 pixels at least. So right now it's not very clear. So in this case, if I zoom in, the image starts to become clearer and clearer. 125, right? So this is recognition. If you go closer, the red zone, that's when you reach identification. Okay. Now, what's the blind spot? From the camera till here, you have zoomed in by 13 mm. So once you zoom in by 13 mm, almost 10 to 11 meters, you cannot see anything. And then you can see the person very clearly. So whenever you have main entrances, you cannot say there is a blind spot, so it's okay, I can sacrifice, I want to see everything. No, it cannot be done. Entrances, main entrances, your primary priority is to get identification because otherwise you risk security. So you have to get this. If you still need to monitor this area, you can have another camera to do that. All right. So if let's say this is not a main entrance. Right now, let's say I'm not looking at a main entrance. This is just a corridor, standard corridor. The person has already entered, waiting area, lobby area, corridor area. So you have already identified him, right, at the entrance. Now you just need to recognize where this guy is going. So in that case, you can go ahead and use a wide angle as much as you can get recognition. So you can use a camera this way. And this particular camera can give you up to 15 meters recognition. For an installation height of 3, you can make it 3 meter. And focal length is 5. So that's why you generally take 3 to 10 mm, 2.8 to 12 mm. Most of your projects will be within this range, except the main entrances where you may need extra lens, right? So this is one. How do you convert this into your field of view drawing? Let's say you have an AutoCAD. When you have an AutoCAD, first to draw a camera picture like icon, draw a straight line of here. Here it's 15 meters, right? Let's look at the top view, 15 meters. So you can draw a line 15 meters and draw a vertical line after 15 meters. After that, there is a horizontal angle 55 degrees. This angle, the horizontal angle is 55 degrees. So you would take 55 by 2, that is 20, sorry, 26, 27. So you will take 27.5 degree, and here you will take 27.5 degree and draw the line angle and then cut it at the 15 meters. So this is your cone. This is your viewing cone. So any camera with a sensor size and a 3 to 10 mm, you can get a maximum distance of 15, roughly 15 meters recognition. So you just say, I need a camera, 3 to 10 mm, sensor size so and so, resolution so and so, every 15 meters. That's your recognition. Okay. So if you do this for one project, you will find out that it's the same for every other project because the coverage actually depends on these parameters, focal length, resolution, and sensor, not really dependent on vendor models. Uh, Very slight impact, but it's not really dependent on that. That's why you can use a we don't have to choose any vendor. You can still do the coverage because it's just formulas which tell you how much you can cover, mathematical formula. Okay. Okay. Now, so someone asked me to explain a bit about body percentage. Body percentage is a very old method. Okay, let me. Okay, body percentage is before megapixel cameras came into mainstream, people were using body percentage. This particular person, if I cover head to feet, this is 100%. If I cover head to feet, I'm covering 100% of the human being. Right now, I'm covering more than 100%, but however, this is 100%. Okay. If I cover from head to just the knee, or maybe just little below the torso, that is, I'm covering 120%. Okay. I'm not covering the full person. I am zooming in and I'm covering uh, from head to just below the torso, that is 120%. So if I look at a person, uh, I zoom in, then cover more than the person, full person, that's 120. Okay, then just a second. Detection. Okay, detection 50%. All right. So, and then you have the recognition and detection. Typically, they say 10% of the entire scene, or if the person height is 10% of the entire scene, that is your detection. And then let's say, let me do the drawing. Okay, let I think it's some delay here. Okay, so let's say this is my screen. Okay, if my person face of the person is here, let's say the face of the person, body, and from his feet you're seeing little bit. Okay, not the entire feet. Maybe the remaining feet is here. So this is 120%. You're seeing full from the screen, from head to feet, you're covering him. This is 120%. However, if you in the screen, if this person you're covering head to feet from top to bottom 100%. If you see in the screen, let's say this yellow box is also screen, if only 50%, all right, so this is your 50%. 10% will be very small. So 10% of your scene, that is 10%. So you just, this is basically detection. This is the old method of prioritizing design. Today we use pixel per meter. This body representation has nothing to do with pixel per meter. It is not dependent on it. It purely depends on the lens. You can you can achieve body percentage even with half megapixel. You know, back then we didn't have even megapixel camera, but we were still following the standard. You can even achieve this with half megapixel, but you need a very big lens. To achieve identification, you need a very large lens. Um, if you need 3 here, you might need 10 to 12 with half megapixel to get 120%. So uh, today we are, or majority of the regions have migrated to this standard because you can cover more and you don't need a uh, basically you if you use body percentage, you're rejecting completely the idea of pixels, right? There is no point in investing a megapixel camera because anyway you're going to just zoom in with the lens to get full 120%. So it can be half mega, it can be 1 mega, it doesn't matter. So what's the point in investing in megapixel? So there should be some benefit. That's why pixel per meter is universally accepted in many regions. Some cities are still following the old, but otherwise, majority of the place we use pixel. All right, let's go ahead. There are also 3D drawings available. This, what we saw is all 2D, two dimension. Uh, if you are using Revit, if you're using BIM, BIM uh, tools, um, you can download files from any vendor. They will have a specific file called they will have a 3D image Revit file you can download and you can directly use it as well. Let me explain. So here we go, BIM Revit. You can use this file and directly you'll get a 3D coverage uh, in your application. So you can directly drop and use this to do coverage drawings. So we have a YouTube video on how to use this. Uh, I will not cover about it too much today because this is a fundamental. 3D is something you can learn in addition to this. So there's a question, what is EN6276? Okay, EN6276. So it's part of the DORIS standard, detection, identification. Sorry. Yeah. Okay, let me pull that out. So the definition, when I said we need a certain level of identification, like certain pixels, this all comes from a standard. So you can, this standard is AN6276 or 50132. Okay, so you can refer this standard, and what you're seeing is a result of that standard. Here we go. Okay. Next is the resolution. Higher the resolution, higher the pixel per meter. Okay, higher the resolution, higher the pixels. If you have a HD camera, 1 megapixel camera, roughly 1 million pixels. If you have a 2 megapixel camera, you have 2 million pixels. You're covering the same scene, but you're providing double the pixels, more details. More details also means more bandwidth, more data, right? So 4K is like 8 million pixels or 8 megapixel. So you're again provide maybe you're using the 4K camera to cover the same training room or same entrance, but you get more detail because you are providing more pixels. So simply put, higher the resolution, higher the pixels, higher the bandwidth, higher the storage, higher the data. All right. The minimum pic resolution used in CCTV is 1 CIF. It used to be quite common 10 years back, uh, 10 to 12 years back. It was quite common for even public surveillance. So if you remember very old days, the CCTV footage used to be so small and blurry because yeah, it was using 1 CIF and 4 CIF. Today it's quite nice. We have a commonly we are using 2 megapixel and many sites have standardized even 5 mega and 4K. All right. How do you visualize 1 CIF? If you take a visiting card, your business visiting card, that's the uh, that's the size of the image. If you print it on a paper, that visiting card size, that's the size of the image quality. If you zoom in, it's going to be looking very bad. If you put it on a 42-inch screen, that visiting card size image, for sure it looks very blurry, right? So the quality is not great. So we don't use that anymore, but it was once the uh, you could say the normal standard before. So that's where we started from. So I have a question. If we use 4K, can we identify a person? Yeah, you can. Yes. So that is one of the benefit of using a 4K camera. You can cover a wide area and still get more pixels. For example, let's say this particular camera. Pixel per meter. Let's my door, this glass door is roughly 1 meter wide. Okay, so if I measure the pixel in this door area, I will know how many pixels are available per meter. So right now, this particular door, I am achieving 250 pixels. So if anyone walks in through the door, I can guarantee I will get identification, all right? Because the minimum for identification is 250 pixels. Now, if, for example, I'm zoomed out, okay, and oh, and by the way, one of you had asked what is IAN 6276. Um, Yeah, so it's the pixel per meter is specified by the standard European standard EN 6276, and there is an older version EN 50132. Okay, so both refer to the same topic. All right, back to this image. Now I have zoomed out. I have zoomed out. Okay, now let's measure the pixel per meter. If a person is walking through the door, I am only achieving 110 pixels. So there is no guarantee you can identify if a person is walking through the door. That's why you need a different zoom lens or to zoom in and get identification. What if you cannot zoom? In that case, make sure you buy a 4K camera. Let me check if I have a 4K around for this location. Uh, okay, anyhow, it's fine. So this is a 5 megapixel camera. At this distance, let's say around 10 to 12 meters, for 1 meter, I'm only achieving 110 pixels. So if I use a 4K in the same location, I will get more horizontal pixel. You have to only look at the first number, H by V, horizontal. This is horizontal. Left to right is horizontal, 110 pixel per meter. I'm only getting 110, not enough to get identification. Even recognition, not good because 125 is the minimum for recognition. Some people say 100, some of them say 125, but roughly speaking, this is just a bare minimum even for recognition. All right. So if you are having no other option, you need to cover the entire training room. You need to still get identification for a person coming through the door. Then you have to change the camera with a higher resolution. But if you are not really concerned about covering the entire training room and you have option to zoom in, sacrifice the viewing area a bit, then you can get identification by double, we can double check. Okay, I need to zoom in further. Focus. 243, all right, close to 250. So now I can get identification. I can zoom a little bit more as well. Now, this is called bare minimum identification. Previously, you saw strong identification. The reason for strong identification is low light areas. You cannot guarantee the same amount of light. You cannot say in a hotel you will have this light. You cannot say at night time parking areas will have these lights. Maybe there will be just one light, or maybe the ambient lighting will be 10 times lower, hardly 10 lux, 20 lux. Right now in my office, it's around 300 lux to 500 lux. Right below this lighting, I can get around 400 to 500 lux. Um, just to visualize, in the night time, if you go in the streets, you can uh, you can download this in your mobile phone. Lux Meter, we will play. Lux Meter, you can just download this app to give you an idea, so you can measure the amount of light. It's available on your mobile phone. On your Android, you can download this. You just show it below the lighting. It will measure the amount of light coming in that area. As you go far from the light will reduce. You keep it under the table, the light will reduce. The lux level will reduce. So you in hotel entrances, the chances are lighting is very dim. Okay. So how do you still guarantee identification? Because identification is a must. We cannot sacrifice what you don't know from which country the guest is coming, and you need to get a clear detail who's in your property. So there, if you have low light locations and you need identification, just jump the requirement to 500 pixels, double the minimum requirement. So for sure, you're not going to miss if anybody's walking through the door. That's as good like 120%, you can compare to that level. So let me zoom this camera. Oh, it's already the max. Okay. 12760. All right. So here, let's say if you want strong identification, so you are able to see the person very clearly, right? So why is that? If you measure, it's almost 200, and also the lighting is good. Now, if I want Okay, oops. Now if I measure, this is okay, it's 1000. So this is still 800. So if someone is walking through the door, for sure I can get his face very clearly. So this is 800 pixel per meter. So this particular camera is a bigger lens camera. That's why I said certain entrances you need long lens. So there are cameras with large lens like this. All right, now let's take a break and then we'll come back for the next topic. All right, let's resume. Next is compression. Here we are focusing on IP camera, right? When you are working with IP cameras or any generally cameras, CCTV, and especially high resolution, um, storage is a big concern. The more resolution you move towards, the more the quality of the image that is needed, higher the storage required. But some of you might have realized previously, let's say, again, I compare with roughly a 10-year period. 10 years back, we were covering the same area, we were requiring the same storage. Even today, after migrating to 2 megapixel, you still require similar storage. 2 terabyte was used for half megapixel 10 years back for one camera. Today also you require roughly 2 terabyte for one day recording for 2 megapixel camera. How is that possible? It's purely because of codec. All right. So what is this codec? Codec means coding and decoding. IP camera, the coding happens at the bottom. The coding happens in the camera and it is done dumped onto the storage. In analog camera, the DVR, the recorder does the coding. All right. Coding is image stream packaged digitally and sent over the network, right? And once you view it on the screen, that is a decoding. Okay. Now, what are the different codecs available? Since 1992, codec started out with JPEG. JPEG was an image. Then we had motion JPEG. Then we had MPEG 4. Then H.264, which is already 15 years old. Then we had H.265. These are the different codecs. What is the benefit of codec? Why do you need a codec? In CCTV, without codec, it is almost impossible to do any project. You cannot supply even one camera for a project. So codec is as important as that. If you take, uh, this is like a thumb rule calculation. If you take a 5-minute video of 2 MP, you require around 55 GB storage without codec, without any kind of compression or if you want to record a video for 5 minutes, you require 55 GB. It's like this. How to visualize, how to understand. Imagine watching a video online. Let's say YouTube video for 5 minutes, and your data package is done, is complete, finished, or used up. Okay. So that's the impact of codec. So YouTube has their own special algorithm, codec algorithm. However, uh, 5 minute, okay, 55 GB. Your data may be, some of you have 10, some of you may have unlimited, but so you understand, right? For a 2 megapixel itself, just for 5 minutes, you are using 55 GB without codec. So how does a camera work? When a camera sends 30 frames, every picture is called a frame, or you can say image, 30 images per second. So image 1, image 2. All right. In image 1 and 2, the only difference is this particular object has moved slightly forward to a new location. Every other detail remains the same. There is no changes. So what the codec does, codec is like an algorithm. It looks at the scene and it decides, all right, most of the image is same, so I will not send the redundant data. So all the redundant data will be reused, okay? And when it is reused, uh, it will send only the difference. This is the difference compared to the previous image. So let's say when you play back your camera or your system, when it decodes, it will automatically merge with the reference frame. The previous one is the reference frame. The difference is called the partial frame. There are other words for the reference frame called iframe, full frame. Uh, cannot hear me? Just a second. Just- Okay. I hope I'm audible. Okay. Okay, great, great. Okay, thank you. I'll continue. Right. So we were talking about codec. What is the power of codec? The main purpose of codec is to let go of redundant data. Now you saw the car here moving from location 1 to B. Now you might think this may not be the case everywhere. Actually, it's the case everywhere because when you are taking a video, the camera sends 30 frames per second. You might just read it as frames per second. It's actually 30 pictures per second. You're all sitting at your desk, some of you maybe on the phone, some of you driving, whatever. But within 1 second, uh, did you move a lot? Did your environment change? Did your tables move? Did the walls move? Did the road move? No, right? So within a second, 30 pictures is a lot of information, and for sure there is bound to be a lot of redundant data, right? So codec is, you can say it is like the bloodline for streaming. Okay. So once you apply a codec, only the partial images will be sent. It's called the P frame. It merges with the I frame when you decode, and the I frame is also called as full frame, key frame. The small one is called partial frame or P frame. H.265 is slightly more beneficial because it tries to take. So right now you see the image is chopped into small blocks, and then it will process within that block. It will just check the redundancy. In H.265, it will take bigger blocks because you have H.265 is good for higher resolution like 4K, 5 megapixel, more pixels are there, right? So it will take bigger blocks and will try to reduce. Perhaps here it will combine the four as one single block with a few differences. So it will reduce even further. It require more processing. H.265 is more processor intensive because of this, because it tries to find more redundant data and reduce the image even further. Now, after this merge, did you lose any data? Not really. It's called the compression. Make sure you don't lose the usable data, right? That's the objective of this codec. So, H.265 is not going to reduce the quality. H.265, although higher compression standard, it is a new method. It actually can improve the image quality in some aspects. Okay, and H.265 will be very effective for higher resolution. It can go all the way up to 50% reduction. But if you take half megapixel and you compare H.264, H.265, there is nothing to reduce. It's already a half megapixel. So there you cannot expect 50% reduction. So you will see H.264, which is almost 15 years old, uh, perform or take a very high bandwidth when you go above 2 megapixel. Today, the moment you go 3, 4, 5 mega, 4K, H.264 takes a very high storage. That's why H.265 comes in the picture. Okay, there are other standards. They are not actually a standard. It's called a vendor specific technology. H.265 plus, some people call Wisestream, some smart compression, zipstream. These are all different technology words used by vendor to reduce the bandwidth even further, above H.265. That's why it's called H.265 plus, additional. On top of that, you add. Okay, you don't create a new codec, you add on top of that some more techniques to reduce the bandwidth. All right, what is the technique? One of them is wherever the scene is idle, you inject less bandwidth. Okay. Then another technique, iframe, right? Every 30 frames, you need one reference frame. Let's say if you're, where is that? You have one reference frame and you have multiple P frames. What if you send one reference frame after every 10 seconds? Because maybe offices are closed, cameras simply looking at the lift. Schools are closed. So what's the point in sending even iframe every second? Just start making more. Don't send every second. Send, for example, let's say 25 frames per second. Iframe is 1, and then remaining P frame, let's say 24. So because offices are closed, the camera can decide, all right, there is no activity at all. Now uh, I will stop sending iframe for more longer duration. So let's say after 10 seconds, 10 real seconds, it will send one iframe and remaining p frame will be 24, 240 minus 1. 239 will be p frames. So one iframe and 239 p frames. So you're reducing the interval. So these are techniques to reduce your storage. Okay, I hope to show you a short demonstration. This can take some time. Let's just let me pull it out. X and V, this guy. Let me make it all high resolution. 5 mega H.265 and Wisestream. So this additional compression, we call it Wisestream, and every vendor have additional proprietary techniques to make it really efficient. You know, because let's say, okay, when I demonstrate, I'll explain it to you. So let's go back to video profiles, H.264. Okay, right now this camera is 5 megapixel. I think there is 208. Just a second, please. Okay, I think, all right. Uh, all right, I will just demonstrate as it is. All right, let's say right now it's around 2.7. Okay, the average will be here around 1.9. Whereas the same thing with H.265 is 1.3 Mbps, 1.8 Mbps, 1.3 Mbps for a 5 megapixel. All right. Now, if I activate Ystream, let's make it high. After 10 seconds, we will get the new average. What Ystream does, or what this extra compression techniques, H.265 plus and Ystream, Zipstream, Smart Compression, what they do is they observe the scene. If there is no activity, they will reduce the size of the iframe even further. They will not inject bandwidth if it is not required. However, if there is a moment, so right now it reduced H.265 became 1.2, sorry, zero point 0.9, H.264 became 1.2. The new average is zero point 0.7 and zero point 0.8. Okay, I divide by 1000 because Mbps, right now kbps. So you can say it's less than 1 Mbps for a 5 megapixel camera, right? This is what the technology does. If there is no activity, it will not do any movement. Okay. However, if there is any movement, automatically it will go up, just like you are waiting at the red light, and when there is a red light changes to green, then you start, right? Same way, the camera will also inject more fuel, more bandwidth as required, and then immediately reduce if not required. All right. So voice stream and these kind of smart compression techniques are very, very powerful. They can reduce the storage a lot without affecting the image quality. And by the way, we only did the voice stream basic technique. Then uh, there is also the dynamic GOV. So let's check that. This is also part of voice stream. So I can explain that. Okay, disconnect and connect. So this is a even more aggressive method. Right now, the bandwidth became 40. That's like 0.004 Mbps, right? Yeah, 40 divided by 1000. So then 0.04. And here you have, or in kbps, 284, 7, 10. So if the bandwidth automatically reduces if there is no activity in the scene. So you can see how drastically it can reduce. Okay, here you can tell the camera to even reduce frame rate if there is no activity. So these extra features some vendors add to their camera to reduce the bandwidth because there's no point recording data which is having no value, right? There's no moment. If there is a moment, automatically the frame rate will go back to 20, 25. All right, let's move to the next topic. Which is better? H.265 is definitely better. Right, right. There is a point where you are asking me to repeat it. Which part? Is it the Y stream part or is it the difference between H.264 and H.265? And I think I will also do the repeat exactly after we finish the session. So for the benefit of others, as we go to the next topic, it's completely different. I will come back to that. Just hope that's okay. Yeah. All right. Wise stream. Okay, wise stream. I will cover that exactly as soon as we finish. I will come back to that. Okay, all right. All right. Next topic is camera shapes. Uh, Inside the camera, the processor may be almost similar. Some cameras may have more features, some will have less features. Uh, but the shape of the camera will alter, will change depending on the application. It's like wearing a dress for different occasion. Same way, you have to have a camera for an outdoor, different. You have to have a camera with a longer lens, a different shape, because you need bow, bigger body to fix the lens. Then you have pinhole cameras. These are inside the ATM machines, hidden cameras. Then stainless steel body camera, microdome camera, transportation mounted camera, bullet cameras for outdoor, dome camera for indoor. First one is dome. The last one is also dome, but it is metallic, so it can be used outdoor. This is indoor, usually for left very small retail shops. You will find small micro cameras, wedge corner mount cameras. This is not the full list, by the way. There are different shapes of cameras depending on the application. All right. Then there are also very bold shapes like multi-directional cameras, 180-degree panoramic view. So let's have a look at a video to explain that better. Okay, panoramic. What is the purpose of a panoramic camera? The panoramic camera is a wide angle 180-degree view camera. I wonder why it's taking some time. Okay, okay. One, two, three, four lenses stitched together as one single camera. This is a panoramic camera. The goal is to get a one clear view all the way from one end to the other end of the scene without any break, without any gaps in between. This is from our previous office in the US. Then we have multi-directional camera. Okay, this is also multi-sensor. That means four cameras in one. Then there is something called multi-directional camera. In multi-direction, four cameras looking in four different directions. Basically, it combines four cameras on one body, single cable, single license if you're using with a VMS, just one cable, but four separate lens looking at four different directions. You can zoom separately, you can do analytics and other features, everything separately, independently, but it will have one cable, one body. And for the installation cost, it's like installing one camera, right? Physically, you need one bracket to install the camera on top of the street. So especially city surveillance, where cable pulling and all is expensive, and these kind of cameras do great justice. One, two, three, four. You can keep it at the bottom or you can keep it on the side. These are multi-direction. Each camera will look at four different directions. This is not a stitched image. This is just a four direction camera. Then there is also two direction cameras. Camera which look at especially longer corridors or perpendicular corridors. When you walk in and then you take perpendicular right. So you need a camera at the corner looking in two different directions. So you can customize the lens, you can choose the lens, resolution and so on. Right, this is a perpendicular location. So this is the objective of this camera. This is from the roof of our office. So one looking at the seating area, the other looking at the walking area. Okay, next comes multi-direction with a pan tilt zoom. Pan tilt zoom. What is the objective of this camera is to look at all four directions. If any incident, there's a moment, automatically the bottom camera will zoom in. Okay, so you have four view and one PTZ view. You can click here, PTZ camera will go there, right? It's like you have eyes all around and you can even zoom in like a binocular. You can zoom in and check what happened. Then comes fisheye. All right, fisheye. The objective of fisheye is to cover the entire room. This is a small grocery shop or a small shop. You can say small. It's not a supermarket. It's a grocery shop. One camera can cover the entire scene. All right. So this is called a situational awareness camera. In case of any incident, you know where the person came from. Maybe he came from this door, right? Or he came from behind. Maybe there is some guy who walked in from here. You can get a full view without any blind spot, without any hidden area. But the challenge is you can't really see the face. You still need a camera at the entrance. But in order to get full view, these cameras are useful. Storerooms, training halls, warehouses, you can use these cameras, data centers, to get a full view. Wherever you have these aisles, and if you want to go for the most cost-effective option, fisheye is a very good solution to have a monitoring of what's going on. And you can have one camera at the entrance. Okay, and fisheye will not always look like this. There is some feature called de-warp. What is de-warp? You can digitally change the way it looks. You can digitally zoom in and find out. So this is the same camera, but it is digitally broken into four separate images. Okay, that can be done. To some extent, you can do that. Okay, so it is a part of this image. You can have different types of mode. You can move left and right and check and so on. Okay, so this is 8 zones. Each zone you can block a separate location. Okay, so we'll see that later on. Panoramic, multi-direction with a pan tilt zoom, and we saw about two direction. Next is vendor product categorization. Um, when you approach any vendor, the common mistake today is there are different series for any vendor. They have high end, they have a mid range, they have low end, they might have another intermediate range. But what's the common mistake today? People think if they get a high resolution, that means I have purchased the highest model from this particular brand. Actually, no, you might get uh, even in the low end category, a vendor might have a 4K camera, 4K resolution. Even in high end, he may have a 4K camera. So resolution is no longer a differentiating factor for vendors. Okay. If you're still being led in that direction, That's just the way to uh, manipulate to get you to think that, all right, you have purchased the most expensive. That's not the case at the best price or something. So the features behind the camera is what makes the camera, uh, what costs the camera. The features, what analytics it can do. What can the camera do by itself? Can the camera think by itself? It can decide by itself if someone is walking in? Can it create an alarm? If someone is going out, if they walk in, it's okay. If they go out at a certain time, can it decide? Can it differentiate between a person and a car? So these are the intelligence in the camera that makes the difference, and that's where the processor changes. Second thing is um, hardware. Hardware in the sense, if you require uh, a longer lens, if you require a low light, or if you require higher IR range, these are not common, right? Higher than the standard is not a common. So those all models will fall under your slightly special category. All right, they can have slightly different pricing. Some Okay, previously WDR was also major difference. Now it's almost diminishing. Almost every camera is WDR. Previously, some cameras were not WDR. So WDR, it takes two pictures. It works twice as fast. So it had a different processor and all that. So they were more expensive, but now it's diminishing. Okay. And of course, you saw multi-direction. They are not a standard camera. They are like four camera in one body. They will be also on a different, it's a differentiating factor. Okay. So uh, I will take our product lineup as an example. We categorize into Q, X, P, and T series. What is our motto behind it? The standard requirement falls under Q. Standard lens, standard IR range, 30-meter IR range, standard shape, dome bullet shapes falls under Q series. Standard analytics, someone is crossing the line, someone is walking in a specific zone, intrusion, basic counting analytics. So whatever is commonly required, motion, tampering, will fall under Q. Okay, then above the standard, I need 50 lens. You remember one of the camera I zoomed in all the way to the door. So a special lens, long lens. I need 70-meter IR. I need stainless steel shape, or I need 15, 20 analytics in the camera. So those are slightly above the standard. They fall under our X series. Artificial intelligence. We have two levels of that. The X series, and then we also have in P series, customized artificial intelligence for city surveillance. Maybe some customer says, okay, I want to do a vehicle stop to vehicle detection, or some um, it could be trash detection. So customized intelligence, customize the camera, COVID solution, mask detection, extra features if they want, multi-directional cameras. So they all fall under your P series. So this is how we are differentiating. Then there are cameras which are used once in a while. Every 5 years, there is a project for a prison. So they might buy, or a border security. You might find thermal camera, oil rig camera, corner mount camera, all under a special vertical series. Okay, we have 2 megapixel in Q, we have 2 megapixel in X, we have 4K in Q, we have 4K in X, we have 5 megapixel in Q, we have 5 megapixel in X. Even in P series, we have mostly 4K. So the differentiating factor is not typically resolution, it is your features, what you can get out of the camera. All right, then the last topic for today is about shutter speed. Okay, let me just review if okay, there are some good questions. I will be answering that immediately after this. Will it be that bandwidth? Okay, so one question I can immediately answer is A four camera, quad camera, it will take four times the bandwidth. Yes, it will take four times. It's like four camera, but physically it uses one cable. All the data will be sent basically four times through that single cable. Yeah, that is true. Then don't make any changes in. So I have a question here in Ystream. Does it make any change in frame rate? Ystream, there are two options. If you want, you can change the frame rate also, or without the frame rate, without affecting the frame rate, you can continue to still get reduction in the bandwidth. So this is what it is. You can see here there is an option called dynamic frame rate. Dynamic, you can tell the camera if there is no activity, change the frame rate. You can say don't go below 12 frames. So you can push that kind of settings into camera. So these settings you may not find in every brand. This is where this extra slight, customizations are made compared to, one brand compared to the other one. Okay. Okay. All right. Then there are more questions which I will be answering as soon as we complete in another 10 to 15 minutes. Okay. Shutter speed. Shutter speed. This is the reason for covering this is not to make you an expert in configuring the camera on the field. Most of you may not be doing it, but the idea is to get an understanding that just because you increase full shutter speed, just because you increase full noise reduction, does not mean the image will become magically beautiful, right? It's a very sensitive, um, they call it the triangle. There are settings, shutter speed, gain, noise reduction, aperture control, amount of light to gather. All this is like a triangle. You affect one side, other two gets affected. One side of the triangle will reduce the size of the other side or increase the size. So you have to find the fine balance between them. You cannot increase everything to the maximum and expect the image to become very good. One good point here is uh, artificial intelligence we have in cameras today. They can decide by themselves, depending on the scene, what kind of settings are required for that, what shutter speed is required. But it's still new, right? It just released. These kind of technology just released. But until today, people are still using this traditional method is you will have a person trying to configure each and every setting to get the best picture. Okay, so what's the concept of this shutter speed? Simple shutter speed. If you Okay, here's a description. How much of time the light is given to enter the camera, right? The camera, it opens its eye, allows the light to enter, it captures the picture, just like us. But how much of time you give, right? How much of time you give for the light to enter, that is referred to as your shutter speed. If you close and open the eyes fast, okay, you allow very less light to enter. Okay, when you close and open your eyes faster, the image will become dark. However, if you do the other way, you slowly open, wait for some time, then close, more light is allowed to enter. Okay, it also depends on how wide you open and how much time you leave it open. So there is another parameter, but right now let's just focus on this time part. Okay, faster, slower. Faster you open and close, image is darker. I will show a video about it. Then comes motion blur. Okay, if you allow more time for the light to enter, that means you still haven't taken the picture. The person is walking through the bus. You kept the eye open, I mean the camera shutter open. Only when it closes, it captures that picture, right? So in the same, before it closed, the person ran all the way towards the bus. So that means when the same picture, the person is at the door of the bus as well as near the camera. So the person is at two different locations before the camera closed its eye to take a picture. So this is a side effect of slower shutter speed. Although the image is brighter, the image becomes more blurry. All right, now let's to explain that, let's go ahead and check here. Okay, right now this is a video. Probably looks good, probably looks fine. Okay, the shutter speed is around 1 by 5. That means in 1 second it is closing 5 times. 1 by 5. Okay, what's the challenge? When I pause the image and take a closer look at the number plate, it's very blurry. Okay, let me open one video. This is a common video which I referred from YouTube, explaining about shutter speed. All right, so let's say this is a roller coaster moving fast. Okay, shutter speed 1 by 50. Within 1 second, you're taking around 50 times, you're closing your shutter and taking the picture. Okay, not good enough. You see, it's still blurry. So for fast moving objects, you have to close even faster. So let's say the person now shifts to 1 by 400. In 1 by 400, the image is much more clear. Okay, again 1 by 50. You see how blurry it is? Then go back to 1 by 400. You are able to see faster moving object more clearer. Okay, 1 by 50, 1 by 520, 1 by 50. If I pause, the face is all smudged. Cannot see the details clearly. Oops. All right. So um, let's close the video.